Hi everyone. My name is Lucy Ethiopia. Welcome to Physics and ICT online lesson. Today's lesson is about friction. By the end of this section, you will be able to discuss the general characteristics of friction, describe the various types of friction, calculate the magnitude of static and kinetic friction. To get more lessons, like and subscribe our YouTube channel. Friction is a force that opposes relative motion between surfaces in contact.
One of the simpler characteristics of friction is that it is parallel to the contact surface between surfaces and always in a direction that opposes motion or attempted motion of the systems relative to each other. If two surfaces are in contact and moving relative to one another, then the friction between them is called kinetic friction. For example, friction slows a hockey puck sliding on ice. But when objects are stationary, static friction can act between them. The static friction is usually greater than the kinetic friction between the surfaces. The magnitude of static friction Fs is equal to Fs less than or equal to μSn, where μs is the coefficient of static friction and n is the magnitude of the normal force. The symbol less than or equal to means less than or equal to, implying that static friction can have a minimum and a maximum value of μSn. Static friction is a responsive force that increases to be equal and opposite to whatever force is exerted, up to its maximum limit. Once the applied force exceeds Fs, max, the object will move. Thus Fs, max, equals μSn. Once an object is moving, the magnitude of kinetic friction Fk is given by Fk equals μkn. The equations given earlier include the dependence of friction on materials and the normal force. The direction of friction is always opposite that of motion, parallel to the surface between objects, and perpendicular to the normal force. For example, if the crate you try to push, with a force parallel to the floor, has a mass of 100 kilograms, then the normal force would be equal to its weight, W equals mg sad face 100 kilograms, 9.80 meters per square second, equals 980 N, perpendicular to the floor. If the coefficient of static friction is 0.45, you would have to exert a force parallel to the floor greater than Fs, max, equals μSn sad face 0.45, 980 N, equals 440 N to move the crate. Once there is motion, friction is less and the coefficient of kinetic friction might be 0.30, so that a force of only 290 N, Fk equals μkn sad face 0.30, 980 N, equals 290 N, would keep it moving at a constant speed. If the floor is lubricated, both coefficients are considerably less than they would be without lubrication. Coefficient of friction is a unit-less quantity with a magnitude usually between 0 and 1.0. The coefficient of the friction depends on the two surfaces that are in contact. Let us see the following example. A skier with a mass of 62 kilograms is sliding down a snowy slope. Find the coefficient of kinetic friction for the skier if friction is known to be 45.0 N. First, let us take out the given quantities. We are required to find the coefficient of kinetic friction mu k. Solution. The motion of the skier and friction are parallel to the slope, and so it is most convenient to project all forces onto a coordinate system where one axis is parallel to the slope and the other is perpendicular, axis shown to left of skier. N, the normal force, is perpendicular to the slope, and F, the friction, is parallel to the slope. For the inclined plane, the normal force is equal to N equals W up tac equals cos 25 degree equals m cos 25 degree because the angle theta is equal to 25 degree. The kinetic friction is given by Fk equals mu k times normal force equals km cos 25. By rearranging the equations, the coefficient of kinetic friction mu k is equal to the kinetic friction divided by normal force equals kinetic friction divided by m cos 25 degree. Insert the values of the quantities in the equation. Then the coefficient of kinetic friction mu k is equal 0.082. Note that the coefficient of kinetic friction mu k has no unit.
That is all about today's lesson. If you have any questions, write on the comments section and the online teacher will reply to you. Do not forget like and subscribe our Physics and ICT YouTube channel. Thank you online teacher, thank you online students. See you in another lesson. Until then, goodbye everyone.